Alright students, welcome. Now today we are going to do the questionnaire session on metals and non-metals chapter. Okay. So let's see, we begin with the 2019 question, that is, explain the following. Sodium chloride is an ionic compound which does not conduct electricity in solid state, whereas it does conduct electricity in molten state as well as in aqueous solution. Alright, now sodium chloride, this is a solid, this is the common salt what we are using in our home, and any solid, in a solid the position of the ions is fixed. The position of the ions is fixed. Now the same solid, that salt, when you are putting it in water, now it does not remain as a solid, it becomes in the ionic form. It ionizes. Alright, so when it ionizes, it can conduct electricity. Even in the molten state also it can conduct electricity. So what answer we are going to write over here, that sodium chloride is an ionic compound that does not conduct electricity in the solid state. So let us write over here that sodium chloride is an ionic solid in the solid state. The position of ions is fixed and hence they cannot carry electricity. They cannot move from their place, alright? They cannot carry electricity. But in the molten form, their bond breaks and ions are loose. Similarly, in solution form, aqueous solution form, the ions are free and hence can move. That is, they can carry electricity. They can carry electricity, or they are good conductors in the molten state. So they can conduct electricity in the molten state as well as in the aqueous solution state. Fine. Now let us come to the next part of this, that reactivity of aluminium decreases if it is dipped in nitric acid. Alright. Aluminium, what do we know about aluminium? That is, aluminium is such a metal that this aluminium on the top of, supposing this is an aluminium sheet or aluminium rod, then what will happen? On the top of it, a thin layer of aluminium oxide develops. In the presence of oxygen, in the presence of air, a thin layer of oxide develops. Alright, it reacts with the atmospheric oxygen to form thin layer of oxide. And then after that, this layer of oxide, this covers the metal, and now the metal beneath this oxide layer, this is protected, this is now no longer exposed to the air, so it cannot react with the air. Alright, so now HNO3, nitric acid, this is a good oxidizing agent. So what happens? Let us write the answer. Let us write the solution to it, that nitric acid is a good oxidizing agent. And hence it oxidizes It oxidizes the upper layer of aluminium. Upper layer of aluminium. But after the formation of upper layer, the metal beneath this layer remains unreacted. Or in other words, the rate of reaction decreases. The rate of reaction decreases. Alright. So reactivity of aluminium decreases if dipped in nitric acid. Okay, now let us come to the third part, that is metals like calcium and magnesium are never found free in state. Now we know the reactivity series, so many times we have written the reactivity series, that is we have the reactivity series potassium, sodium, then calcium, magnesium, aluminium, zinc, alright. So that is, we have written so many times, we have one phrase also for this, Kedarnath ka mali aloo zara feeke se pakata hai. Copper, silver, gold. Alright. So for this, we know that highly reactive metals like calcium and magnesium. Calcium and magnesium, they are highly reactive metals. So when they are highly reactive metals, they will not be found free in state. They will be found in their salt form. That is, they will be found such as in calcium carbonate or calcium chloride, or similarly magnesium chloride or magnesium carbonate, whatever it is, they will be found in their salt form, and they will not be found in their free state. So we will write that calcium and magnesium are very reactive metals and are placed high up in the reactivity series. Therefore, these metals are found as their salts and not as their free state. Alright, free state, which metals are found? Which are very low in the reactivity series, that is silver, gold, and up to some extent copper, but silver, gold, platinum, they are found free in nature. Alright, coming to the next question now. Write the steps involved in the extraction of pure metals in the middle of the activity series from carbonate ores. How is copper extracted from its sulfide ore? Alright, let us see the first part of it, that is how these reactive metals, they are extracted from their carbonate ores. So in the middle series, we can take an example of zinc. Alright, zinc or calcium, whatever you can take. Carbonate ores, it is written specifically from their carbonate ores. So from their carbonate ores, first what it is done, these carbonate ores, they are heated. Heated how? In the absence of air. This process is known as calcination. When it is heated in the absence of air, it is called calcination, and this becomes zinc oxide plus carbon dioxide. Alright, now this zinc oxide, this is reduced with some active elements such as carbon, and this forms zinc plus carbon monoxide. Zinc plus carbon monoxide. So this is how, that is, first step is calcination is done. What we will write, that first step is calcination. Calcination of the ore, and second step is reduction of the oxide to obtain metal. All right, we have written the equations also. That is, first step is we do calcination of the carbonate ore, and second is we do, after getting the oxide, we reduce these oxides. Okay, now let us come to the B part of it. How is copper extracted from its sulfide ore? Alright, how is copper extracted from its sulfide ore? Explain the various steps supported by chemical equations, and you have to draw a label diagram of electrolytic refining of copper. This is again an important question. How is copper extracted from its sulfide ore? Alright, so copper from its sulfide. Copper sulfide, we write it as Cu2S. This is known as copper pyrite. The name of this ore is copper pyrite. Now over here you can see there is no oxygen in it. So now we have to turn this to oxide. So what we will do, this is in the presence of oxygen, it is heated. This process is known as roasting. Alright, roasting of ore, and this becomes Cu2O plus SO2. Cu2O plus SO2. Alright, now this Cu, if you balance this equation, then this becomes 2O2 over here, and we may write like this way. So this becomes 3O2 over here. 3O2 over here. So this is Cu2O plus SO2. Then in the next step, what happens? When some of the Cu2O is formed, this Cu2O, this will react with the ore Cu2S. So what will happen? Cu2O, this reacts with Cu2S. Alright, this reacts with Cu2S, and now what is formed? 6 copper plus SO2 is formed. Alright, so the first step, that is roasting of sulfide ore. And the second step is the roasted ore is mixed with some more sulfide ore and heated. Alright, and heated to obtain copper. So this is how we are doing the extraction of copper from its sulfide ore. Alright, so we have explained the various steps we have done up to here. With different chemical equations, we have explained this. Now this part, that is draw the label diagram of electrolytic refining of copper. Let us do this part. Electrolytic refining, we have to explain it with the help of a diagram. Electrolytic refining, how we are doing. In electrolytic refining, what happens? We have to first form the electrolysis cell. Alright, so this is We call it as electrolytic cell. Electrolytic cell. In the electrolytic cell, we will take an electrolyte, that is copper sulfate aqueous as an electrolyte. Alright, now we have two electrodes. Two electrodes, what we will be having? One electrode is a thick one, and this thick one, this is an impure one. Alright, this is impure one. So this is impure copper which we want to purify, and this is made as anode. Alright, this is made as anode. That means to the battery you will connect it over here. And another cathode, what we are making, this is a thin copper wire. Alright, so this is thin copper wire, and this is made as cathode. This is made as cathode. Now when you are passing electricity, what will happen? Copper from this electrolyte, this will deposit on this thin cathode, and from anode copper will go in solution, and all the impurities will collect over here as anode mud. As anode mud. So this is what you have to prepare. You can also show like this way, that Cu2 plus will go from here to this cathode side. Alright, and copper from here will go in the solution as Cu2 plus. Alright, so this is what it is required to draw a label diagram of electrolytic refining of copper. This is electrolytic refining of copper. You have just got to draw the diagram, and diagram itself explains how, that is how much you know. Okay, coming to the next question now. Coming to the next question, a student added a few pieces of aluminium metal to two test tubes A and B containing aqueous solution of iron sulfate and copper sulfate. Now when aluminium metal is added to iron sulfate and copper sulfate, so we know that aluminium is high up in the reactivity series and copper is much below in the reactivity series. You know that aluminium is more reactive than iron, is more reactive than copper. So what will happen when aluminium is added to iron sulfate and copper sulfate? Then this will, iron sulfate is green color, copper sulfate is blue color, so it will change its color. This will become aluminium sulfate. This will also become aluminium sulfate. In the second part of her experiment, she added iron metal to another test tube C and D containing aqueous solution of aluminium sulfate and copper sulfate. In which test tube or test tubes will she observe color change? On the basis of experiment, state which one is most reactive metal and why. Alright, so let us see this. See, let us draw this first, that is see, student added few pieces to two test tubes A and B. Alright, so let us see first. Let us see A and B. In the A and B, A has got, in the A, the solution is iron sulfate. So that is, this is FeSO4 and aluminium metal is added to it. In the second also we have got copper sulfate and aluminium metal is added to it. So we have seen that aluminium is more reactive than iron, is more reactive than copper. So what reaction will take place over here? This will become Al2SO4 whole thrice. Alright, SO4 whole thrice, and over here also this will also become Al2SO4 whole thrice, and copper will become free. In the C, another test tube, C and D. Now C and D, what they are containing? Test tube C. Test tube C contains aluminium sulfate. That is Al2SO4 whole thrice solution. Aluminium sulfate and copper sulfate. Which test tube will she observe? Another is D, is it contains copper sulfate. CuSO4 solution. Alright, in these solutions they are adding iron to it. So iron is added to it. So what will happen over here? You know, iron is more reactive, aluminium is more reactive than iron. So over here there will be no reaction. But over here iron will change the color of copper sulfate. Over here this will become FeSO4 and copper will be released. So in which test tubes will she observe color change? Which test tube she will observe? She will observe color change in A test tube. Then she will observe color change in B test tube, and she will observe color change in D test tubes. On the basis of this experiment, state which one is most reactive metal and why. So most reactive metal is aluminium because it is displacing iron and copper, and the other metals, iron is not able to displace aluminium from its solution. Alright, so aluminium is the most reactive metal. Alright, coming to the next question. Next question, write the steps involved in the extraction of pure metals in the middle of the activity series from carbonate ores. How is copper extracted from its sulfide ore? मैम ये क्वेश्चन रिपीट आ गया.